Welcome everyone to today's program. My name is Alec Cooley. I'm a senior advisor here with Busch Systems, and I'm going to be your moderator for today's program, as well as for the other programs in our ongoing Green Thinking webinar series. For those of you who have not joined us before, these are a series of programs we do roughly every month, every other month, and mostly focused on waste and waste reduction related topics. But as we'll be jumping into in just a moment, today's focus, we're going to be focusing on Scope 3 inventory when assumptions meet data, and looking sort of on the upstream side. So as I said, we're going to be taking a little bit of a detour from our normal focus to look at efforts to better understand and control the greenhouse gas emissions and other impacts that are caused by the way that large institutions consume materials. Excuse me there. We talk often about the need to reduce and reuse materials, but universities, government agencies, and other large organizations still need to be able to purchase products as part of their regular operations and as their and how they operate. And like waste and recycling, traditional efforts to reduce the impacts of these materials we consume have largely been based on assumptions in the past, guessworks. We use policies like the EPP, environmentally preferred policies with recycled content and others to drive procurement decisions, but a lot of this is still based on a lot of guesswork of where we think we're having impact or not. But in recent years, as we're starting to see more life cycle analysis studies and other assessment tools that are coming out, they're helping us to better inform how we get and use this data to drive some of these institutional decisions. We're still in the early days of understanding how we can track and apply this data, but they point to growing opportunities to better prioritize how we operate and consume materials with our large institutions. Today, we have 4 presentations that we're going to be focusing on with today's program. We're going to be starting off with Brandy Sebastian, who is a technical director and senior LCA strategist with John Beath Environmental. Brandy's going to be giving us more of a primer, an overview of Scope 3 emissions and how and current efforts to track those. We'll follow Brandy with a presentation from Patrick Sagana, who is a senior sustainability advisor with Polytechnique Montreal. And then after Patrick, we'll have Karen Cook, who is a sustainability project manager with Alameda County in California, in the California Bay Area. And then we'll follow up at the end with presentations from Andrew Sheehan, who is a director of sales and marketing with Carbon Graph, as well as my colleague Mackenzie Bradbury, who is a sustainability and eco-impact coordinator here at Busch Systems, talking about some of the efforts that we're doing at Busch around carbon accounting. So before I hand it over, obviously we have everybody's lines muted, but we want to make this as interactive as possible. We're going to be holding questions and answers to the very end, but if you have questions at any point during the program, please drop those into the Q&A function on your Zoom dashboard. Specifically, if you have questions that you would like to have the speakers address and respond to. If you just want to have comments, your own experience, some examples, resources, other things that you think would be helpful that you want to share with others, we encourage having discussion in the chat, and so feel free to use that. Just note, if you have a question you actually want speakers to respond to, that will need to go into the Q&A function, and that's how I'll know to pull those out and verbalize those at the end of the program. So with that said, let's go ahead and jump right in. We're going to start off, as I said, with Brandy Sebastian, who is a technical director and senior LCA strategist with John Beath Environmental. And with that, I'll hand it over to Brandy. You should be all set to advance the slides now, Brandy.
Great. Thank you, Alec. Let's see. Excellent. So good afternoon, everyone, or good morning, depending on where you're located. As Alec mentioned, I'm Brandy Sebastian. I serve as the technical director for LCA and sustainability activities at John Beath Environmental, also called JBE. This presentation was prepared with support from JBE's LCA practice lead, Zevda Rosenbaum, and is meant to set the stage for today's panel with some context and introductory information about life cycle assessments, scope 1, 2, and 3 greenhouse gas inventories. Very briefly, before we get into the content, a quick remark about JBE. This company was formed in 2015 by John Beath to disrupt typical consultancy models. We're a small firm with about 20 engineers and scientists who support clients with sustainability services ranging from LCA and carbon footprints, development of environmental product declarations based on LCA information, greenhouse gas inventories, emission reduction plans, including science-based target setting, supplier engagement, packaging, waste recycling, and circularity assessments. Great. And so I wanted to start with the basics of what is life cycle assessment. LCAs have been done since arguably about the 1970s, when Coca-Cola first did an energy analysis of their company that expanded into a comprehensive environmental burden analysis. LCA takes many forms, but at its basic level is a method or an approach to assess potential environmental impacts potential environmental impacts and human health impacts throughout the life cycle of a product, a material, or even a service. So the most common metric that one assesses in an LCA is global warming potential, which also means aggregated greenhouse gas emissions, and it's often referred to simply as carbon. And I'll talk a little bit about why that is in a few slides. Though some assessment methods look at more than 15 different environmental impacts. LCA is standardized there are various ISO standards that govern how you conduct LCA. It's also a very iterative process. And this shows the basic framework you follow that ISO established. It starts with defining the goal and scope of a study. This is the step where key decisions are made, such as whether you're looking at the impacts across a company or an institution, the impacts of a specific product or set of products, or the impacts of delivering a specific service. You can also determine if you want to look only at greenhouse gas emissions or broader impacts, and whether you're looking at the full life cycle from cradle to grave or a specific part that might be of interest. Once your study is defined, data is collected for each process or life cycle stage within the boundary that you have set. The data is analyzed and then impacts are calculated. And during interpretation, the results are analyzed and conclusions are formed around things like where are the hotspots within the life cycle or supply chain, and where might additional, more precise data be needed. One of the key benefits of conducting an LCA is to inform decision-making and assess the potential for trade-offs across life cycle stages or across different impact types. This helps avoid unintended consequences that could result from improving the environmental performance upstream, but those changes creating additional impacts in downstream life cycle stages, such as how materials are managed at end of life. Another common trade-off we see is material shifting. So some studies have shown that switching from plastic materials to bio-based materials may lower greenhouse gas emissions in some instances, but can also increase water consumption throughout the material life cycle. This chart shows another way of looking at the system boundaries. This is an example of a manufactured product showing a complete cradle-to-grave scope, including all steps from acquiring raw materials from the earth or recovered from the technosphere to the manufacture, distribution, use, and end of life of the product and the materials it contains. In this case, a cradle-to-grave assessment would include most scope 1, 2, and 3 categories in a greenhouse gas inventory, which I'll cover in just a moment. Okay, so don't worry, I'm not planning to give a math lesson with this slide. The purpose of it is just to illustrate that while LCA may seem complex, the calculations behind it are very simple. So for example, the emissions that are leaving the system boundary set to the left here are assigned what is called characterization factors. And those factors tell us how much and what type of impact each of those emissions cause. The amount of emissions are multiplied by the factors, and then they're summed up to get the total impact of each type. LCAs focused only on greenhouse gas emissions can be developed in Excel instead of software, but software is often very helpful to streamline the process and look simultaneously at other impacts. And just for your understanding, the boxes labeled AP and EP here stand for two other commonly assessed environmental metrics in LCA studies. AP stands for acidification potential and is an air quality metric indicating the potential for acid rain formation. EP stands for eutrophication potential, which looks at nutrient loading on land and waterways, which may lead to issues like problematic algal blooms. These two impacts are more regional in nature, whereas climate impacts are global, with greenhouse gas emissions like CO2 traveling across the globe and remaining in the atmosphere for hundreds of years after emitted. Okay, so now that we know a little bit about LCAs, let's shift our focus to greenhouse gas inventories, which are really just a specific application of LCA. So like broader LCA methods, greenhouse gas inventories or carbon accounting follow specific guidelines. There's ISO standards, but most often the greenhouse gas protocol is followed for this type of assessment. That document pioneered the concept of scope 1, scope 2, and scope 3 emissions. But before I get into the details of that, I wanted to first mention that carbon accounting includes a set of greenhouse gas emissions. Those are listed at the top of the slide here. Some of them don't actually include any carbon. They're characterized, as I talked about previously, based on the amount of atmospheric warming they cause, and are often summed up to a single value expressed in carbon dioxide equivalents, or CO2e. So there's many reasons to conduct this type of assessment. Collecting data across a company or an institution allows that entity to determine where the greenhouse gas hotspots are in order to set reduction targets that are meaningful and actionable. And it can also allow for the tracking of progress over time, providing robust data to investors, customers, or other stakeholders that are asking for the information, and even to attract and retain new investors or talented employees that are increasingly interested in the impact of the organizations they're working for. The graph in the middle shows the Science Based Targets Initiative Net Zero Standards typical pathway, and that involves quantifying a baseline inventory, setting near-term targets, specifying long-term emission targets such as 2050 or earlier, and then creating a plan to neutralize any emissions that cannot be reduced inside the entity value chain. So for those of you that are not as familiar with the different scopes of a greenhouse gas inventory, this graphic explains what they are and the typical sources of those emissions. Scope 1 emissions are the most straightforward. They're associated with facilities and vehicles that are owned by the reporting company or entity. And so they're within the direct control of whomever is reporting the emissions. Scope 2 are upstream, meaning they're outside of the reporting entity's control and are caused by purchased electricity, steam, heating, and cooling. Scope 1 and 2 emissions are typically easier to quantify with readily available data and are commonly reported in sustainability reports of the companies and organizations each year. Scope 3, on the other hand, is divided into upstream and downstream activities, with upstream typically meaning things that are fed into the reporting entity's operations, like purchased goods and services, capital goods, and fuels. Scope 3 downstream includes things like items leaving the entity's control, like the use and disposal of any products the entity may produce. Often a materiality assessment will be conducted to determine which categories are significant given the purpose and the structure of the reporting entity. For example, a company that makes consumer products will often see the majority of its impacts are in purchased goods and services, and the use of the products that are sold if they consume energy, as well as distribution of those products depending on how much they weigh or how massive they are. Institutions may see the majority of their impacts in their buildings, purchased services, and business travel, on the other hand. So going back to the discussion of LCAs, the data collected for a product level LCA often excludes capital goods, business travel, commuting, and investments, because on the scale of an individual product, or even the total products produced in a year, these categories typically become too small to appear in the results. However, for a company or a service analysis, they may be significant. and should be included. So this is just a short recap of some of the key concepts, and then I have two brief case studies to share. So whether you are conducting an LCA or greenhouse gas inventory truly comes down to how you define your study scope. Greenhouse gas inventories are LCAs that focus on an organization instead of a product, and they often look only at greenhouse gas emissions. The methodology and the calculations to conduct both are very similar, though they may follow different standards that look more specifically at the application. Greenhouse gas inventories often rely on spend data for some scope 3 categories. And so this can be very efficient depending on how much information is within those categories. And it's often large amounts of data, but it can create challenges when you're trying to achieve more granular information and insights that are necessary to develop a greenhouse gas reduction strategy. So LCAs can make greenhouse gas inventories more precise, particularly for scope 3 categories like procurement. We're seeing trends in all market sectors that are going towards increasing specificity of data, including manufacturer-specific information, even facility-specific details, and supply chain-specific footprints. So if you're procuring goods, materials, or services from others, engaging with your suppliers and asking for their data in the form of LCA or lifecycle inventory data can help make your own assessments more accurate, and can also open the door to conversations about how they are addressing their own impacts that in turn affect yours. Okay, so just two quick case study examples to hopefully help illustrate the points. So JBE does some work with large consumer product manufacturer clients. Ahead of the project shown on this slide here, JBE conducted a detailed company-wide analysis and hotspot deep dive showing significant impact in the raw material and packaging of the products it is producing. The aim of this particular project was to help the company assess key life cycle stages of all of its products and identify hotspots within the product and packaging types and develop strategies to reduce greenhouse gas emissions. So given the large portfolio of products, differences in how they were packaged and what they were used for, and how they were treated at end of life, an LCA scenario analysis tool was developed to calculate baseline product footprints and also allow the company to modify product design, raw materials, packaging types, and end-of-life management options in order to inform its corporate greenhouse gas reduction strategy. So the tool was designed as a heat map to look at impacts across different life cycle stages for different scenarios to see where trade-offs may occur. In this instance, the tool looked at greenhouse gas emissions, fossil energy consumption, and water consumption. And it identified a potential for significant carbon reductions if the company were to prioritize selling concentrated refills in their product offerings versus single-use packaging that was often recycled, but still had to be managed one time after use. In another study, we worked with a large food service industry client to analyze its scope 3 emissions to respond to investor demands and also the growing interest from customers on the impacts of the food they were consuming at restaurants. So we developed a scope 3 calculation framework to develop a baseline and efficient scope 3 assessments in the future, and then identified hotspots and opportunities for science-based target setting and achieving emission reductions. So the company's scope 1 and 2 emissions in 2023 were nearly 800,000 metric tons. But after analyzing their emissions, we found their scope 3 emissions were nearly 3.5 million metric tons. Approximately 80% of those scope 3 emissions came from purchased food, beverages, and packaging. And this presents an opportunity for this particular company to then engage with its suppliers for impact reduction and more meaningful relationships. So with that, I'll say thank you. I'm happy to take any questions you may have as part of the panel, and I'll hand things back over to Alec.
Great. Thank you, Brandy. I do just have one quick question that came in that hopefully is a quick one. You can just answer right off. And that was, is there a distinction made between a company's value chain and supply chain? Are they the same thing? Are they different? Is there a sort of quick response you could give for that?
Yeah, I don't think those terms are very well defined. Yeah, supply chain and value chain do seem to be used interchangeably. Yeah.
Okay, great. Well, thank you. Let's thank you for just that general background primer. Let's just jump right in next to our next presentation, which will be with Patrick Sagata, who is the Senior Sustainability Advisor with Polytechnique Montreal. And Patrick, I'll hand it over to you.
Yeah, I don't seem to find the controls. Buttons are not. Oh, here we go. Okay, I think. Yeah, thanks. Okay, thank you, Alec. Thank you, Brandy, for setting the stage. Very interesting presentation. So I'm going to present an institutional carbon footprint or greenhouse gas inventory analysis done in a higher education institution. So as Alec mentioned, I'm at Polytechnique Montreal, which is an engineering school located on the University of Montreal campus and affiliated with the University of Montreal. We are the largest French language engineering school in Quebec, which makes it safe to say in North America. We have 12 undergraduate programs and about 10,000 students, of which 7,500 are full-time. About 2,500 postgraduate students and faculty and staff, maybe 2,500 people, but about 1,600 full-time equivalent. So to give you an idea of the size of the institution. I will just give really quickly a little bit of background on the project, present how we did this institutional carbon footprint, the methodology, results pretty quickly, and maybe some thoughts to share and to ponder upon based on this data. So we joined back in 2019. We joined 10 other Quebec university institutions and several hundred around the world in the Race to Zero campaign. So we were achieved to committing net zero carbon by 2050 at the latest, hopefully earlier than that. So for that to be meaningful, well, we have to know what we're talking about, right? Where the data comes from. So, you know, Brandy mentioned very clearly what the objectives are of doing such an exercise. Determining the main sources of emissions, basically to see what our targets should be, where we should focus our efforts, and what the impacts of attacking these sources of emissions will be, and of course follow the evolution of our over time. Today I'll be presenting the 2022-2023 fiscal year analysis. This is the second we have done. The first one was for 2016-2017. Seems a long time between the two, but we had a pandemic, of course, in between. So to analyze data from the pandemic year would not have seen a very efficient use of our resources, given that it would be in no way typical or representative of the years to come. So we used what we call a hybrid life cycle approach. I'm not sure that's the terminology that's used everywhere, but it is accepted. So which means that according to what sources of emissions we are measuring and what data we have available, we adopt our approach. So we adapt our approach, we adopt different approaches. So it's a combination in our case of process database, which is something you can do when you have physical data, when you're talking about scope 1 and 2, mostly combustion on site of fossil fuels, electricity, or other things that we can easily have quantification of, and I will give some examples after. And input-output database for financial data. So this is what Brandy was mentioning. When all you can do is convert dollars, because you have a ton of suppliers and products and services that are too different or too rare or unique sometimes to get supplier data. So for the what we call the input-output approach. We use a database developed by CIREG, which is actually, we're lucky, it's a research center which Polytechnique Montreal is part of, is one of the players. They develop a database called, they feed a database called OpenIO Canada, which uses industry inventories of emissions and of gross domestic product data to calculate emission factors for various industries. This sounds a little bit theoretical, but I will get into to the detail. So when you use process database, what it means is you do a certain number of activities within your company or institution, and you actually have physical measurements of flows, so kilograms, kilowatt hours, and so on. So this is, like I was saying, easy to do for certain things. For energy, because you normally know exactly how much electricity you're consuming, how much natural gas or fuel you're burning, and so on. Food, because databases for food, when you have food services in your institutions, are pretty easy to obtain through velocity reports from your suppliers, for example. Water consumption, water waste, other waste management, and so on. For other things which are significant, it's feasible but not so easy for staff and student commuting, for example, staff, faculty, and student commuting, because theoretically you could calculate each person, how many kilometers or miles do they commute each day, how many days a week do they come, what mode of transportation do they use, but you don't have obviously access to all that data. You can survey it, and I'll get into that later, but you don't have full data. For business travel, it's feasible also because in theory, you could, since your business travel is normally documented and paid for by the company, you could know who is going where, when, for work, with which mode of transportation, and so on. And there are factors where you can work down to CO2 equivalent emissions for flying, for driving, and so on. In our case, being a university, we have a lot of travel for research, and typically a professor will buy their own plane ticket and have it refunded after. So the information on the actual transportation mode is buried under a few layers of paperwork. So it's feasible if you can do it, but not always easy, especially in a university setting. Even some large universities will have sort of a traveling service in-house, almost a travel agency in-house for this type of thing. So that would make it easier theoretically because it would be centralized. But I've heard of many institutions where even if they do have such a centralized system, only about 20% of travel actually goes through there. So as I'll show you, we don't use process databases for that, even though we could. Input-output database is a totally different approach where, like I was saying, on a national base, in our case in Canada, we know that for such and such an industry, the industry emits as a whole so many tons of CO2 equivalent. They are worth so many dollars of gross domestic product per year. So it's making it sound simpler than it is, but you can work down each dollar you spend in a certain type of goods and services to a equivalent CO2 emission. So this is easy to do for almost everything. Why? Because we normally keep our books pretty much in order, so we know where we spend our money. Unlike other data, we have financial statements that are audited and so on. So it's pretty easy to make sure you cover everything. And in fact, it's probably the main advantage of this type of approach because you're going to cover everything. You're not going to leave something behind. If you start scratching your head and looking through all your physical data, you're definitely going to miss something. Not ideal for fossil fuel combustion. Why? Because it would tend to underestimate it, first of all, and second of all, it's so easy to get physical data for fossil fuel combustion. Why would you avoid it? What it misses, though, is what's not in your books. So things that can be associated to your activities, such as your staff commuting It's not something you pay for, so it would not show up in a process like that. In such an approach, you have to find other ways of getting that information. So we're talking about system boundaries. So for us, our system is 1 year of operations for Polytechnique. So just touching on very quickly the scopes through the GHG protocol established. So scope 1, as was mentioned, is everything that you burn on site with your activities. So in our case, it's mostly natural gas, which we use for heating. We do have a small vehicle fleet, but very almost negligible, because we do have a couple of off-campus sites, but they're not very far off. So it's not very material, but we still calculate it because it's easy to calculate. Electricity, of course, for scope 2, and scope 3 is basically all the rest. So purchased goods and services. Here I separated our own plus our food services, because our food services are covered by a not-for-profit organization, so they're not in our financial boundaries, but since they're 100% dedicated to serving our community, we included them in there. Capital goods, then there's fuel and energy indirect emissions, so it's associated to fossil fuel and electricity, but that's not scope 1 or scope 2. Waste and wastewater. Here we cheated with respect to the GHG protocol, because we lumped, business travel is fine, it's in the commuting. We cheated a little bit because we lumped together our staff and faculty commuting, which should count as an upstream emissions, and our student commuting, which should count as downstream emissions, because in this type of analysis, students are considered like our clients or our customers. But since we get the data from the same place, from a survey for everybody, we lumped it all together. Leased assets and some financial activities. And to get an idea quickly visually of where we get our data, well, what you see in blue is where we used financial data using an input-output approach. And physical data is the stuff that we can actually measure with physical quantities and calculate GHG emissions based on that. So what we get sort of is this 2x2 grid as to where we get our data. So we can have physical data and make sure that it's complete for stuff like food services through velocity reports, as I said, and fossil fuels. That's one example of where we have physical complete data. Financial data complete applies to really most procurement. As I said, we normally know where we spend our money and how much of it we spend. Now, we have physical statistical data for commuting. So what we do is we survey our community, both staff and students, and we ask them, okay, where do you live? We do go by zip code to calculate distances. How many days per week do you commute? Which, of course, before the pandemic was usually 5, but now can be significantly less. What are your modes of transportation? And how many weeks per year do you come? It isn't the same if you're an undergraduate student as if you are a faculty or staff. So we take a sample, we take a survey, and we extrapolate to the entire community. Now, I guess theoretically you can find some financial and statistical data, but I don't really see a practical example of that, since your financial data is almost always complete. Unless for some reason you need a quick and dirty answer and you only have like 1 month of financial data, maybe, but I mean, it's not normally this type of exercise you do is not something that you do like live on the fly. It's once a year is closed. So what do these calculations look like? If you're using like an input-output approach for supply, this is where most of the work goes into, at least the first time you do this exercise, because for each general ledger code in our books and general ledger description, you have to find the code in the database and the description that matches it most closely. So we have a couple of hundreds of these, of course, like probably many of you do. So in our case, for example, the 40316, to take an example with goods, which we call lab supplies, corresponds to this code, which is medical, dental, and personal safety supplies, instruments, and equipment. Very, very broad description but that's what it is. So in our fiscal year, we spent this much money, 3.1 million Canadian dollars. Now, this input-output database is not updated every year. It's updated every few years. So we have to adjust this number for inflation to the last year where this was updated. In our case, it was 2019. Anyway, long story short, for this general ledger code, we can attribute 293 tons of CO2 equivalent. For services, it's the same thing. Like for an insurance of goods here, well, same thing. There is an input-output item called insurance brokerage and other services related to insurance. $511,000 equivalent to 37 tons of CO2 equivalent. So that's when you're using financial data to estimate emissions. If you're using physical data, well, then there's other databases that can be used. Echo and Vent is what we used in this case. Now, here it can be a little tricky because sometimes the databases the information you'll have will be on a life cycle analysis base, and other times it won't be. So for example, for electricity, we have our Department of Natural Resources who gives us every year what the emission factor is, and it's per province because each province in Canada has pretty much its own grid mix. So you can work out according to the emission factor you find. If it covers the entire life cycle, then you've got the whole life cycle footprint here. And when you calculate in this case, the scope 2 emissions, you got to subtract that to calculate the scope 3.3 emissions and so on. For natural gas, same thing. You can find data on just production and distribution. Data for combustion is quite easy to find. So you basically split up your total LCA footprint between scope either 1 or 2 and scope 3. In this case, 3.3, which is the indirect emissions of scope 1 and 2. So where does that bring us once we go through the whole exercise? This is our figure of emissions by scope. So the total emissions of Polytechnique for 1 year are a little over 20,000 tons of CO2 equivalent. You'll notice you only see 2 pie slices in there. It is not a mistake because in Quebec, because 99% of our electricity is hydroelectric, well, the scope 2 is almost negligible. So that is the case for Quebec. For British Columbia, pretty similar, but for other places, both in Canada and in the US, it isn't the case. However, what is typical of universities and higher education institutions is that scope 3 is normally not necessarily the majority, but at least a very significant part of emissions. Clearly the majority if you have very low scope 2, such as we have in our case, but in either way, you know, literature will say that for universities, it could be between 20 and 80% of emissions that are scope 3. And scope 3 is very broad, is basically almost defined as everything that's not scope 1 and 2. So we really have to dig into there to see where we can get most bang for our buck in working on reduction. Now, another approach I like to take is instead of going through scopes is to look at activities, because as I showed you earlier, for example, fossil fuel combustion, yes, it's mostly scope 1, but it also has some scope 3 emissions associated to it. So I prefer to take an activity approach, which makes it also easier to speak with your people and to get messages across more easily. Okay, what are we actually doing that produces most greenhouse gases? So I've highlighted here procurement, which is the largest contributor of scope 3 of everything, actually, 9,400 tons. It's almost half of our entire carbon footprint. By procurement here, of course, I exclude everything that's already in under categories. So like, let's call it general goods and services purchasing, because of course, natural gas is also purchased. So is business travel, so are food services, not commuting, as I mentioned before, because we don't pay for it. And so on. So beyond, you know, the easily identifiable and targetable contributors, which are what I call my big 3 unique contributors: natural gas, commuting, and business travel. Procurement is really a big one that it's worth digging into. Before I do that, though, Notice the absence on this chart of waste management. Now, of course, it is there. It's in the miscellaneous here. But I single it out because, you know, we're not a manufacturing facility, we're an institution. And when you ask people, you know, how can I make the institution more green? That's the first thing that people will single out is, oh, look at all this waste we're generating, and look at all this waste that's not going into recycling. Sure, it's really visible. And I'm not saying we don't have to do anything to improve and to take care of it. But in terms of global warming potential, it's really not something that's very material. So getting into the procurement portion, I'm going to dig into this orange bar here a little deeper. So these are those 9,400 tons per type of item. So on top, we got services, which is a third about of that, almost equal with specialized equipment. Of course, we're a research university, so here you've got all kinds of research equipment that goes into there. Major improvements on buildings, supplies, general supplies. This can be paper, this can be everyday lab supplies, consumables, and so on, and other stuff. Now, again, what I've singled out here is the supplies, because more often than not, when you look at sustainable procurement policies or environmentally preferable purchasing stuff, it'll focus on that a lot. You'll often hear about, okay, let's buy paper with recycled content, let's locally source this and that, and so on. You know, which may be true in many companies and many industries, but in a university setting, it isn't really that important. I mean, 1,400 tons is 1,400 tons. I don't want to neglect it, but if you got to focus on what really matters, it's these two up here. Now, it's pretty difficult to get a handle on emissions associated with specialized equipment, because, I mean, how many transmission electron microscope suppliers are there out there? And how much clout can a small university like ours have on, hey, you guys, can you do something about reducing your carbon footprint? Maybe not tomorrow morning, but, you know, it's good to know it's there. Services, this is, you know, came a bit of a surprise to me, because, you know, we think of services as being something that's not material in the sense of physically material. It's just like the cloud and whatever, but, you know, there is a carbon footprint associated to services as well. So I decided to look a bit deeper into that bar there, the services. What are we talking about exactly? It's a lot of consultancy fees, lawyers' fees, HR firm fees, and training. People who come either on site or we go over there and give them, we send our people to be trained somewhere else. I'm not talking about the actual, like, the transportation part of it, really the actual training. It could be architects and so on. So that's half basically of our services. Services related to goods. What I mean by this is, for example, insurance of our vehicles, maintenance contracts on some equipment that we have. It could be leasing spaces outside of our campus. So there's that there too, which is pretty significant as well, and lump together everything else here. So I guess that's about it. Just a few thoughts maybe to leave you with. There are limits on thinking everything in terms of GHG protocol scopes. First of all, because when you translate it back to activity, well, mustn't forget that there is scope 3 hidden behind the other scopes, as I told you before. There's a scope 3 emission associated to natural gas. There's a scope 3 emission associated to electricity, for instance. And when you're, when you want to send a message and discuss this with management and other stakeholders within or outside of your company, it makes more sense to talk in terms of activities rather than GHG protocol scopes. And to where to find places to work on and to prioritize your efforts, I would say follow the money. First of all, as I said, the money. When you base on financial data, you're more likely to capture everything that you have, or at least not forget anything. And probably, you know, I was talking about supplies surprisingly not being such a big contributor in our case. Probably, you know, where you spend most money is probably where you emit the most. So that would be the first place to look, other than the obvious, you know, if you're burning coal in your facility. I mean, it's a pretty easy one to address, or at least to think of. But after that, when it gets into scope 3 and more like difficult to pinpoint stuff, look where the money is going. And, you know, this is probably a lesson I took from how important services were contributing to our footprint. Just because it's dematerialized doesn't mean that it's not material in the GHG sense of the world, or in the sustainability sense of the word. It could be very important, even though it's not material. I like to say, to remind people that in spite of its name, the cloud, when you're talking about cloud computing, the cloud is not immaterial. It's actually has some physical phenomena associated to it. And yes, I just saw very quickly in the Q&A something about Cabo's guide for estimating scope 3 emissions for universities. I did give that link to, or that guide to Alex, so he'll be able to share it with you at the end. Thank you very much. That's it for me.
Great. Thank you, Patrick. That's fantastic. There's a lot of information there to dig into. And I'll just point out again, we'll have the presentations and the slides are all being archived after today, so you'll be able to access them if you want to come back to these after the fact. And we'll be sending out an email in the next few days how you'll be able to link those, as well as some of these resources that Tyler, my colleague, is be dropping into the chat. Patrick did make a reference to Cabo and the guide that they published to help with estimating scope 3 emissions specifically for universities. The other resource that I want to throw out there specific to colleges and universities, for those of you familiar with ASHE, the association focused on sustainability for higher education, they've had a work group. This has been meeting over the last year of sustainability and procurement folks looking at these scope 3 emissions also, and they've had a whole series of webinars and topics, again, focused very specifically on scope 3, how to better track and all that. So you can find that also is another link that is in the chat here. With that, let me welcome Karen Cook, who is the Sustainability Project Manager with Alameda County, and is going to give us perspective from a county level on what they're doing specific to Scope 3. Karen, I'll hand it over to you.
Thank you very much. Yeah, Karen Cook. I'm a Sustainability Project Manager here in Alameda County, which is located on the east side of San Francisco Bay. Pleased to be here with you today. I want to talk about our journey. I come from actually a waste management background into an environmentally preferable purchasing program development here at the county, and then started looking into how can we tie purchasing and climate action, because climate action is got a lot of momentum. Purchasing, hard to get attention sometimes. So I'm going to talk about our journey towards that, and it'll build quite a bit on what you've heard so far. So hopefully some of this will start to really sink in and make sense. So I want to start with our motivation. You know, we have a mature and robust EPP program, and we're ready to move on beyond the low-hanging fruit initiatives. As Patrick was saying, you know, office supplies, goods can be important in you know, a focus of EPP programs. But what else could we do? How could we tackle some bigger things? And we knew that the scale of opportunity was significant based on our research and learnings from others. And we really wanted to work more strategically to target the biggest sources of impact in our supply chain. So we undertook a journey of completing a few sustainable supply chain analyses. And actually our first one was even prior to the ones listed here, and it was done in-house by an intern. So that's a very doable thing, especially now with some of the resources available. But we did more formal inventories with good company. We did it for our countywide expenditures in 2015 and 2019, mostly working with our spend data. But as Patrick mentioned, we did look at actual process data for the fuel and energy use. We wanted to focus our work on greenhouse gas emissions, but also look at a couple of other impact categories. So we had human health measured by PM 2.5, and then a few other measures here. And that gave us a sense for kind of those trade-offs that Brandy was talking about earlier. But also kind of we could speak to certain departments who had different focuses than we did about this work and be relevant to what their focus was. So in looking at, so after we looked at the impact categories, we identified kind of where the major hotspots in our supply chain were. We did a deeper dive that I'll talk about a little bit more detail into the sources of the impacts within the supply chain for 13 specific purchasing categories. So that's a big picture overview of what we did. And you can see a link at the bottom here that has all of our reports posted, as well as some other background information about our journey. So high level, just comparing our 2019 spend and our 2015 spend results for greenhouse gas emissions by purchasing category. We had over 85,000 line items in 200 product categories that we purchase. We rolled them up into 7 meta categories so we could look at the big picture. And we identified where are the biggest sources of impact, where in general can we focus our attention. And I wanted to show this because it shows a little bit of consistency between 2019 and 2015. You know, some changes around the edges, but professional services and construction maintenance are both high. And then we have the other categories listed that are smaller contribution. So I show that to show that, you know, these inventories, they're based on spend primarily. If you're spending the same amount year over year by category, you're probably going to get similar results. So this is a targeting tool. That's what I like to think of it as. Where do we want to focus? And then we need to dive deeper to figure out what to do and how to measure results in our work. So the second thing I want to highlight is a comparison between what we call our government operations inventory, which is not specific to scope 1 and scope 2. We throw our employee commutes and business travel in there, but it's the things we have a little bit more control of as a government organization. So that's the blue bars there, and you can see the amount of emissions in those 4 categories we've broken it into. And then we compare that to our supply chain emissions in the yellow bars. And the finding here we see is that supply chain emissions are a big opportunity. They are 4 times bigger than our government operations inventory. Now, this is really apples and oranges in terms of our level of control, our ability to impact change. But because there is such an opportunity here, we do want to look at it. We do want to incorporate it into our climate action planning. And I want to highlight that the professional and community services for our organization as a county government organization is 50% of our supply chain emissions. And these are primarily from contracted services who are serving our most vulnerable citizens, providing healthcare, elder care, childcare, and mental health services. So as an example, so that's about 88% of that tall yellow bar. Cities, other types of organizations may not have that level of it, but a county government organization, that's our bread and butter, is serving our vulnerable community members. So that is not a surprise. We spend a lot of money there. Although it was a surprise as we embarked on this effort. But now that we know that, it makes sense. Okay, so now we know where the big targets are for emissions, and we want to analyze, okay, for those hotspots, what are the actions we can take to address the major causes of impact in the supply chain? And can we identify actions that will reduce local health impacts, especially PM 2.5? And so we asked our contractor to dive deeper into the data. We used the Environmental Protection Agency's USEEIO data. It's a environmentally extended input-output model, similar to what Patrick was talking about. They used. It's a free, open source data set. And you can dig into that data and find out what's contributing to greenhouse gas emissions for any specific impact category of emissions. So this figure comes from our report. It is for construction services. And when we're looking at climate change measured in greenhouse gas emissions and these other impact categories, the contribution to that impact category is measured by the length of the bar in percentage. So the orange bar is vendor fuel and water use. So when we look at all the different top emissions categories in the list at the very bottom, the vendor fuel and water use contributes the most to climate change, to human respiratory issues, to PM 2.5, and to human toxicity. So for 13 product categories, we have this type of analysis as well as description of where those sources of impact are coming from, and suggestions for how to address those impacts through our purchasing activities in one-page fact sheets as part of our report. So it's a great resource to look a little deeper and find out what is where you can take action. And I've linked the actual report that this figure comes from. So what do we do with this information? We know that it's impactful. We know which general products it is. We've looked deeper to find out the sources of impacts in the supply chain. So now we have to take action. So I'm just going to walk through 3 different groupings. Our professional and community services, those emissions are really coming from the operational emissions of our vendor. Their electricity and natural gas use to power the vendor's facility, the fuel they use to travel to serve clients, and if they're serving food, then it's the embodied carbon in that food. Those are the major sources of emissions in that community service facing, that 88% of that tall yellow bar you saw earlier. So what are we doing about that? Oops, sorry. We have developed a new initiative that we probably would never have looked at if we were just focused on, our traditional EPP efforts. But with this broader scope of supply chain, we're building out a vendor sustainability program where we're working to provide resources to our vendor community. These flyers are for childcare centers that identify sustainability resources, and we're pairing that with emergency preparedness resources because we know these folks are serving our community. We want them to be able to rebound in the face of emergencies, and especially with more frequent climate emergencies that are occurring. So this just brings resources to them, and it may be that we transition to more requirement-based, but we need to balance the ability for these vendors to provide services to our most vulnerable with any costs that we're layering on top of them. So for now, we're really focused on supporting their sustainability. If we transition to construction and maintenance, these emissions are mostly coming from the production of materials, especially concrete and steel, and fuel used in construction equipment. So one of the initiatives that I'm really love to talk about is our low carbon concrete initiative that we began in 2019, we participated in a project that Marin County led. They received a grant from our local air district to bring together a multi-stakeholder group to set locally relevant global warming potential limits for concrete. And then they adopted it, their board adopted that as a green building code for construction projects in their county. And what we did was we participated in that and really built our capacity to understand what was happening with that. And then what we did was we took those limits, those global warming limits that they had approved. They're relevant to us because we're neighbors essentially across the bay from them. And we incorporated those limits into performance specifications for our construction contracts. When we hire a vendor to build a building for us, we tell them, you must not exceed these limits for the material. And those are specific to the different strengths of concrete. And there are, ability to do trade-offs in certain areas, but that is how we are promoting low carbon concrete in our own construction. And so there's lots of resources and background. You can learn a lot more about it and about the code project. Our partners at Stop Waste are hosting a lot of that information at the link there. And then our own county performance specification we've posted to our website. You can get the link there. And finally, there's kind of everything else, right? And a lot of that is goods or fuel or food. And these sources of emissions, if we look deep into the data, are typically from resource extraction, production, and transportation of those goods, food, and fuel. So to address those pieces, we can certainly buy better, right? We can buy the recycled content. We can buy the energy efficient. We can do all of those things. But even better than buying better is buying less. So an initiative that we are actually launching this week is Alco Reuse. This initiative is an online marketplace. We have a warehouse for surplus goods from county departments. We're building an online marketplace that makes it much easier for departments to identify lightly used equipment. We're focused on ergonomic equipment because that's a big spend at the county. And it's just increasing our ability to do reuse. And I want to leave you with just a few resources. If there are a lot out there now, the West Coast Climate and Materials Management Forum has done a trends analysis report. If you don't have the ability to do your own analysis, you can look at this report and look at where are the trends in higher education and public agencies and utility agencies. There's also a how-to guide if you want to do it yourself. And I've got a tip here on switching from an old, outdated model to EPA's new USEEIO data set. So you'll have to make that change yourself, reading over that how-to guide. Another thing you could do is look at a comparable organization. And if you're looking at their spend and your spend and you're saying, oh, those are pretty similar. We have all those types of services we provide in our organization, then you could also just kind of take that as a back of the napkin type of analysis and look at what the results are. And then if you're interested in kind of diving a little deeper, the Sustainable Purchasing Leadership Council is a membership organization, and they do have climate and purchasing focused cohorts that they run regularly, and that's a great resource for folks who want to dive in a little deeper and can join. So I will leave it at that. This is one of my favorite topics. If you have questions, you want to look at what we've done a little more, feel free to give me a ring. So thank you. I'll turn it back over to Alec.
Alec, it looks like you're muted.
Thank you. Thank you, Carol. That was a great presentation. Lots of good information there. Yeah, I know Tyler's been dropping the links to some of these embedded links from Karen's presentation into the chat. And again, I'll just point out that we'll have all these will be available archived after the program, and we'll be sending out an email to access these if you're not able to catch them right now. Let's go ahead and just move straight into our last presentation, and then we do have some questions coming in, and again, encourage folks to add some more. And I'll just point out we're a few minutes over the hour. This is I'm targeting this probably closer to about a 90-minute program overall. So our next program presentation is going to be a brief one, but then we'll be jumping into the Q&A. So before I do that, though, let me bring up Andrew Sheehan, who is Director of Sales and Marketing with Carbon Graph, as well as my colleague Mackenzie Bradbury, who is the Sustainability and Eco-Impact Coordinator here at Busch Systems. And they're going to be talking about some of the work that we've been doing here at Busch to better understand our products and where some of the impacts are from those and how those can be used. But from there, I'll just hand it over for Andrew and Mackenzie to explain further details.
Awesome. Well, thanks, Alec, and hello, everyone. I'm Andrew Sheehan. I lead business development at Carbon Graph, and we provide a software platform for tackling lifecycle assessments and product carbon footprinting in supply chains to help our partners move from using assumptions towards data-driven decision making. And that's really our entire mission, is to make the impacts of purchased and manufactured goods and services visible. So whether that's for our enterprise partners directly or public institutions, academic departments, or supporting our consulting partners, we're working to build better tools to make it easier to quantify these impacts and share that data across the supply chain to build cleaner businesses. We met Craig Busch back in 2022 as he was looking for a way to assess and communicate the environmental impacts and intensities of the Busch product family. And so we thought today, what better case study than the work we've done with Busch Systems. And to that end, we're going to provide a quick 5-minute overview of some of that work and how Busch has been starting on this product carbon footprint and lifecycle assessment journey. And as we've heard today, lifecycle assessment is this kind of systematic data-driven approach to sustainability that helps remove some of any kind of fuzzy logic or biases in making these decisions. And so one of the things we're fond of saying at Carbon Graph that we've borrowed from the software industry is think big, start small, and scale fast. And in all of our engagements, we set out typically to answer some fairly big questions, like what are the carbon intensities of our products? How do we use that data to design, deliver, and manage our offerings more sustainably? How do we share that data with our supply chain partners so that they can make more informed purchasing decisions? And that's step one, is thinking big. Step two really is, how do we not get overwhelmed by these big questions, and how do we actually get started, start small, and ideally pick a project that we can learn from and scale up that operation really quickly. And so what we typically recommend doing is picking a flagship product where we can go from setting a goal and scope to building an inventory, collecting supplier and reference data from databases, and running those impact assessments and starting to interpret those results. And so starting small was getting in touch with Busch Systems, working with Megan and Mackenzie, the Busch Systems Sustainability and Eco-Impact Coordinator, and picking a flagship product that Busch Systems wanted to understand before scaling up operations. And so that single flagship product, I'll just briefly walk through how we've worked together over the last year, was one of the most popular bins at Busch Systems. And over the course of about 4 weeks, we worked with Mackenzie and team to identify what information do we need to collect from our own internal operations as well as our supply chain partners. And we met every week, typically for about an hour, and walked through from goal and scope all the way to interpretation of these results. What does it mean for us? What does it mean for our partners? And from there, Mackenzie was able to take that process that we built out for the first product, and you can see we're building this kind of visually on the right side of your screen there. How do we take these processes, take our internal data, match it with reference data from the largest peer-reviewed databases similar to, and including EcoInvent, like Patrick mentioned, and how do we scale this up? And Mackenzie has since, over the course of about 6 months, been able to scale this to almost 90 different product carbon footprints across 37 different product families, and take those insights and start sharing them with supply chain partners. So if I have one piece of advice, it's, start small, pick a flagship product, get some buy-in from the organization and your supply chain partners. And if we all start doing that, we'll be able to share this data much more effectively. And with that, I'm going to hand it over to Mackenzie to talk through what's being done with that data now that it's been collected and assembled. Mackenzie.
Amazing. Thank you, Andrew. So as mentioned, my name is Mackenzie, and I'm the Sustainability and Eco Impact Coordinator for Busch Systems. And like many of you here at Busch, we are passionate about maximizing our environmental and social impact. And that's exactly why we began this journey of quantifying and reducing our product carbon footprints. So we partner with Carbon Graph to track the carbon footprints of our recycling and waste containers. And through this partnership, we have made discoveries that allow us to make intentional environmental improvements to our products, as well as empower our customers to make informed, eco-conscious program decisions. So for environmental improvements, the first key outcome of this partnership is the opportunity to make meaningful environmental improvements. By tracking our product carbon footprints, we are now able to pinpoint specific areas within our supply chain where we can most effectively reduce emissions. Through the expansive Carbon Graph database and software, and with the help of the Carbon Graph team, we were able to compare materials and manufacturing processes. These comparisons allowed us to quantify the benefits of our sustainability initiatives, such as our incorporation of recycled material in our products. So within a few of our product lines, for example, we compared using raw high-density polyethylene versus a post-consumer high-density polyethylene, and found that the use of recycled plastic could reduce a product's carbon footprint by about 50%, which we found to be very significant. So quantifying our sustainability initiatives allows us to refine and set intentional sustainability goals for meaningful climate action, and we plan to continue to work with our suppliers and research and design team to make effective improvements and reduce scope emissions. And we also have customer empowerment. So in addition to opportunities for environmental improvements, another key outcome from our partnership with Carbon Graph is how the information we have gathered can empower our customers and our partners. So on our website, we include a product carbon footprint number on our carbon footprint landing page and on our individual product pages. And by clicking on that footprint number, partners can access a comprehensive product dashboard, which you can see here on the screen, and that includes detailed descriptions of the model, standards, carbon intensities, and additional data points like life cycle stages and aversion history. So this transparency allows our customers and partners to witness and participate in our progress as we move toward our reduction goals. And customers can also utilize this information if they're tracking their own Scope 3 emissions, or if they simply want to make sustainable choices. And we hope that this quick 5-minute overview has been helpful. And if you're not sure where to start, please feel free to reach out to myself or Andrew. We're happy to answer any questions or get connected. And with that, I will pass it back on over to Alec.
Great. Thank you, Mackenzie and Andrew, for sharing that. I know I've been excited, which is we've been going through this process to see and better understand, with our own products, how we're doing that. And that gets to something I want to touch back on with some of our discussion as we move forward. But let me go ahead. I'm going to turn off the slides right now. And if I can have all our speakers turn on your cameras. And we'll take a few minutes to take some of the questions that have been coming in and go from there. But let me start off with there's one question I think sort of embodies what some others have been also getting at, and it's been covered in pieces, but just to be real explicit, when we talk about how we're tracking emissions, again, many of our traditional folks who come for these programs focus on waste. And we want to think about materials management perspective, and how do we account for the emissions related to what we consume and dispose of. But real roughly with the Scope 3, we sort of we're dividing those and cleaving those in two, and we're looking at it at two different perspectives. There's where we're tracking emissions related to the downstream, which is the methane that comes from landfills, and other aspects, the hauling related emissions, et cetera. And then there are the upstream emissions related to how the materials that we're producing are being the emissions related to that, to the materials we consume. Is there, I guess, any other explanation or explaining sort of the distinction between how those emissions related to materials, or does that more or less cover it? Sorry, that wasn't a very easy question, but
well, Alec, I'll just
Yeah.
pipe in here. I'm a non-technical person, so I would say your description seems reasonable to me. And I think the thing that I wanted to just share is that what I've seen is that often those upstream emissions are way more significant than what happens to landfill or anything else. So that's why, in my trajectory of work, I've gone from the waste management side to the purchasing now to, well, how can we drive change in our purchasing? Because that's where the impacts are happening. So I just wanted to kind of build on that distinction that you mentioned and why it's so important that we work in this area.
I might add on to that, Alec. I mean, unless I'm wrong, normally what you generate as waste stems from something you bought in the first place, right? So if you are purchasing and you have data based on an LCA approach, well, the end of life should, in a way, be already calculated into that and considered. Now, we like to still, do our own analysis to just, if only to see, are we really wasting that much or are we not? How much are we diverting from landfill and so on? But in our case, we're not a manufacturing facility, right? So we don't generate tons of waste. So there's ways, like, for example, if you're diverting stuff, sending it to composting facility, sending it to a recycling facility, you can certainly the standards allow you to count credit for that, for not selling to landfill, because the upstream it's already been counted in the upstream. We don't do that because we're not really 100% sure. Well, actually, we're pretty sure that everything we send to a recycling facility will not be 100% recycled, of course. So we just take a conservative approach, and just so in our estimation, we count transportation to either to the landfill, to the recycling facility, or to the composting facility. We count a certain emissions factor for landfill. There's no incineration of waste in the Montreal area, so we don't have to worry about that. And we do not, like I said, we do not calculate credits for recycling or composting. But again, like in our situation, it's low and almost negligible. It doesn't mean that it's the same thing for everybody. But I concur with what Karen said about, focusing on the upstream more than the downstream. And I probably didn't mention it enough. For all these purchases you do of goods or services where you're not really sure how to have an impact on it, of course, reducing the amount of goods and services you purchase is the first place to look, obviously. It's not reduce, reuse, recycle, it's reduce, 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 and then do the rest.
Yeah, absolutely. So let's dive down that path a little bit further. Certainly we know what we consume is a big part of where we can make reductions, but as it's been pointed out, we're still dealing with sort of a blunt instrument in terms of just the data that is available right now. Mackenzie and Andrew just pointed out some of the work that's been done, with our bins. So in theory, if somebody's looking to make purchasing decisions, do we foresee the data getting more granular and being available on a broader level to allow procurement policies to make decisions between one product and another? That's very hard to do right now because there's not a lot of data out there. But do we see that as a trend, as a realistic possibility in the coming years?
I think that's certain. Oh, sorry. Go ahead, Karen.
No, go ahead, please. Steve.
Yeah,
I was going to say, I certainly think that's the goal and something that we want to be a part of. I think it really starts though at the organizational level, starting to track this information yourselves. So yeah, Karen, I'm curious to hear your thoughts on this at Alameda County.
Yeah, I think the high-level supply chain analysis, using your spend to target your activities, is it's the targeting tool. And then you dive in and you find other tools to do the more detailed work. So that, for example, the low carbon concrete work, we're not going to measure that with a spend analysis, our success around that. We're going to look at EPDs, environmental product declarations, as a tool to see how much global warming potential is in the concrete that are going into our buildings. And that's the tool we'll use to measure when it comes to a specific product. So you target, you use the macro tool to target, and then you start using other tools to measure impact.
Yeah, I fully agree with this. It's kind of the scalpel that comes in afterwards. I think one of the really cool things we're seeing is one of the biggest challenges in life cycle assessment and product carbon footprint data is the regionality of data and how things are treated very differently in different locations. We heard Patrick talking about hydro in Quebec and not having any incineration facilities. One of the really cool things I think we're going to see is starting to leverage a lot of machine learning to regionalize some of these data sets, always with, practitioner overview, but there's a huge opportunity there to make data much more accessible on a regional basis and much more powerful as a result.
Yeah. Good. Brandy, is there anything you would want to add at all to these points?
Yeah, I think, the other panelists have made some really good points. We're seeing trends in this direction. There's been market signals coming from large purchasers of materials and services to the companies that are making those products, and then even back into the materials that are going into those products. And so the best way to make sure that information becomes more readily available is to continue sending those signals, continue asking those questions. I completely agree. The hotspot analysis is a really good place to start, and then you can figure out what's really important to go back and do further analysis. One example, one of the case studies I talked about, the large consumer product manufacturer sent, those signals into their supply chain, into their suppliers. And we're now working with one of their largest suppliers to develop a program to footprint the materials that they're sending to the clients, the specific materials that are going to those clients. And so it's a trend that we're definitely seeing, and it's one that I think will just increase, making more data available in the future.
Yeah. One thing I'll share, not part of these presentations, but I did see another webinar recently as part of the ASHE's Scope 3 program with a presentation from Stanford University. And I thought something interesting they were doing is, they're starting this process of actively asking vendors, give us information that you do have, and putting out the signals, looking to identify who are the sort of the low carbon service providers or vendors that they can be working with. And at least in the early stage, there's not a whole lot you could do just because you don't have a whole lot of data, but their hope is to be able to sort of accrue and accumulate this data about different vendors and different products over time so that, down the road in the coming years, they'll have enough of a database they can use that to actually start to shape purchasing policies based on that. But as with all of this, this is still we're clearing the path and figuring out how to actually do this and how to pull this together. So there's a lot still to learn, and as we move forward. I'll take another question just from our attendees. One was from Sahar, and Patrick, you already responded directly to this, but Sahar's question was, what do we do with double counting when Scope 3 is being accounted for in one entity is probably the Scope 1 of another entity? Could we talk a little bit about sort of these boundaries and understanding where does data get accounted for, and how do we know that we're not double counting or missing things altogether?
Maybe I could add on to my to my response to Sahar, or let somebody else go first. I mean, we are double counting, and you're right. Theoretically, if everybody on the planet calculated and reported all their Scope 1 emissions in the same place, we'd cover the whole of it. But in effect, I mean, A, it's not happening, and B, just because there's somebody else's Scope 1 doesn't mean that you as an organization who's purchasing their goods or services can take ownership for it. I mean, I cannot just, increase my business travel recklessly in my unit and say, well, who cares? It's up to the airline to have electric planes, you know. So I mean, I know that there is an emission there are emissions associated with such and such an activity, even though they can be regarded as somebody else's emissions. I'm still creating the demand for it. So yes, in a way it's double counting, but I don't see it that way. I don't think we should look at it that way from the perspective of our own institutions or businesses.
We need our own signals internally. Yeah, good. We'll take, let me take one last question from Gary put in here. Could states develop model LCAs for a typical local government in their own region so that local governments don't have to spend a lot of time and money studying the problem, and also not have to rely on using data that may be from a totally different areas, you know, to the point Patrick made about energy sources, et cetera. But do we see any potential for that something to be done on a local, regional level or state level?
I'd be curious to hear your perspective on this, Brandy, and some of the tools you've been developing with John Beef. But I think there is a huge opportunity for this templatization of LCA. And some organizations will always be hesitant to share some of that data. But if we can figure out a way to do this in a relatively trustless way, yeah, it seems like there's massive economies of scale there in figuring out this big data problem.
Yeah, I completely agree. You know, today's practice, LCA is adaptable to almost any scope that you want to study. If you have a service, your scope looks very different from if you're manufacturing a product, or if you're studying the effect of a project you're working on. So yeah, a lot of effort goes into just analyzing your boundary, doing some upfront research. The point of economies of scale is really important. You know, if there's a template developed that captures the main key points in the life cycle or the scope for a local government, it would then be easily used by others with that upfront work being done already. Yeah, I mean, and so we're starting to see moves in that direction. You're trying to make the processes more efficient. We're all learning a lot, but today it is very, like I said, iterative and very customized. And I haven't seen, a specific local government model being developed by anybody, but certainly sounds like there could be, the need for that.
And I will just reiterate that if you're looking at spend analysis, if your spend is similar to another organization who's done an inventory, then it's the outcomes will be similar, right? So if you have a public agency neighbor who's done a inventory and you provide the same type of services in your agency, you can back of the napkin say it's probably going to be pretty similar. So I will just kind of reference you back to the resources at the West Coast Climate Materials Management Forum. If you're a public agency or higher education institution, there are some good resources there that can help you do that back of the napkin.
Great, thanks. Well, we're getting to the end of our time. Let me pull up a couple more screen again and just share a couple things. As I pointed out earlier on, the recording and the slides from today's program, as well as all these resources that have been both from the slide decks and also that have been going into the chat, all of these are going to be posted on our website over the next day or two. We'll be sending out an email to everybody who registered once those are actually posted and available to access. And also just wanted to point out that in addition to today's program, all the programs that we've done on a whole range of topics over the last 3 years, from organics to different collection, best practices, reuse, waste prevention topics, healthcare, et cetera. All of these you can find on our website. If you go under through the navigation to resources, and from there to webinars, you'll find all these archived. And then next month, we're going to be taking our focus back to K through 12. We've covered this a couple times in the past, but we're going to be bringing in some more case studies, looking at different aspects of K through 12 waste reduction. I know we're looking forward to one presentation on shifting from disposable food trays from cafeterias to reusables, and how we do that shift back over will be one example. And we'll have some other case studies as well as part of that. So look for that announcement over the next week as we nail down the exact date. And then finally, for those of you who are colleges and universities, I want to give a shout out. We mentioned this last month, but we're in the process of doing a survey of collection practices from indoor locations, looking at uniform bin standards, centralized collections, food waste from administrative and academic areas. We would love, if you're with a college or university that has not already participated, we're keeping the survey open for through the end of this week, and then we're going to be publishing the results as part of a white paper, and be doing some presentations around this to better understand some of these trends and how we move towards some of these best practices that can have a real impact on improving diversion, reducing contamination, et cetera. So you can find this QR link right there. We'll take you to the survey, and we'll also be sending out more information after the program. If you are participating in a certification program or looking for CEUs for different programs, I know greeneducation.edu is one example of an organization that gives credit for attending these Busch System webinars. But if you need a certificate of attendance, feel free to reach out to my colleague, Tyler Bailey, at the email address below, and we can provide that just to verify that you participated. We'll be sending out a survey as soon as you shut off this program today. You should see a prompt for this, and there will be an email coming out tomorrow. But we'd love to get your feedback that we can share with our presenters and help improve the program. And then finally, just one last thank you to each of our panelists, to Brandy, Patrick, Karen, Andrew, Mackenzie. I appreciate you taking the time to put together these presentations and participate with this program. So thank you very much. And with that, we're at the end of our official program. I'm going to sign off, but before I do so, I'm going to hand it over to my colleague, Bryan Wojcik, with our sales team. For those of you who are not familiar, Busch Systems, we are a maker of fine products for bin products for recycling and waste. These help to fund this program and make it available. So I encourage you to stick around if you're interested and learn more from Bryan about some of the products that we do have available. So Bryan, if you want to turn your screen on, I'm going to sign off and give the hand over to you, and thank you. I'll let you take it from there.
Perfect. Thanks again, Alec. Good afternoon, everyone. It's a pleasure to see everyone again. Rather than doing the typical sales pitch that we do at the end of this, coming from the sales team, I just want to keep it moving on the carbon graph conversation. Basically, Busch Systems has a very wide variety of products manufactured from various different materials. So from powder coated steel to melamine to plastic steel combination, full plastic. So obviously each carbon graph detail is going to be different based on the product line. As Mackenzie had discussed in her presentation, the team has worked many months to get that process lined up and get all those details available. So the great thing is now, if you go to our product or our webpage, www.buschsystems.com, and go to a product landing, whether it be the Spectrum or Aristata series, what have you, you're going to see a carbon number, which is great. The great thing about that, you get the overall number, so you can gauge that for your needs. But if you click on that, it will then bring you to the carbon graph site, and it gets more detail involved. So it gets all those breakdowns from scope 1, scope 2, scope 3 that they were discussing in the presentation. Personally, what I love is you can see as we progress as a company and change our manufacturing processes, so that we're, more conscious about that carbon graph. We can fine tune that. So you see various versions of as we improve the product line as well, which is great. So what I would recommend, if you're a Busch customer, thank you. Reach out to your sales representative. They'd be happy to fulfill that information and provide that to you. If you're not a Busch customer, please feel free to reach out, and we will start you in that journey and help guide you in terms of what products would be best for your needs. Customization, again, labels, graphics, bins themselves, As a manufacturer, we can work for based on your preferences. So again, please feel free to reach out to your regular sales representative, reach out to our general email line, and someone will be happy to get back to you and start that journey. So is there any questions? And again, I didn't get very specific today in terms of the product, but key point, wide variety of products available, and we're happy to work with your needs. So if I'm not sure if there's any questions, but please feel free to put them in there. Yeah. Well, I don't think there's many questions coming in. So again, I appreciate your time today. Again, if you have any questions in terms of your carbon journey, please feel free to reach out, and we're happy to start that journey with you or continue along with the journey that you've already started. So again, which materials are going to be best for low carbon? Again, a full plastic bin is going to have a lower carbon rating, possibly over a full metal bin is going to have a higher impact, as somebody else jumped in and said. So again, all those details are available on and for all of our product lines. And then as we fine tune, those carbon numbers get adjusted as well. So you can see our journey as well, you know, as we continue to fine tune. Now, Gary has, again, I don't have those carbon numbers in front of me to relay, but our Aristata series is a melamine body with a stainless steel lid and then plastic liners. So you're going to see, you know, a very different carbon number, and it breaks it down within the website so you can see what are the key contenders. It just doesn't provide a number. You can see where all that's coming from, but that's going to have definitely a higher impact than, let's say, a smaller, as I break the building, a smaller full plastic bin. So definitely there's going to be variation there. I'll wait one more minute to see if any more questions pop up. Well, at that, I think we're done. Again, I appreciate everyone's time today. I hope the details were, thanks for doing this carbon analysis. We're happy to do it. And again, we're happy to help you in your journey. So please reach out. But I'll end it there. Again, if you have any other further questions, we're happy to help. And yeah, we look forward to working with you. Thanks, everyone. Have a great afternoon.
All right. Thank you so much, Brian. Thank you for everyone attending, and we hope you all have a great day.